Let's look at the topic of sampling and probability. In this topic, we're going to see how a random process, which is an entirely unpredictable event, will over time lead to predictable outcomes. This is going to be a first step in understanding why randomness is so important in research, and we will cover several more steps in the units ahead. But let's begin here with some definitions. A random event is an event that is determined by chance. The outcome of such an event is uncertain. An example is if we select a random unit from a sampling frame, we do not know which specific unit we will obtain until after we have sampled. Similarly, we do not know which characteristics we will obtain for our unit until after we have sampled. So if we sample, for instance, from an undergraduate college roster, we do not know prior to sampling whether an individual unit that we sample at random will be a freshman, sophomore, junior, or senior. So the concept of random event is pretty straightforward. It's simply an event that takes place due to random processes. And the random process that I'm focusing on here is random sampling. The probability of a specific outcome of a random event is the proportion of times the outcome would occur if the event was repeated many, many times. So the key here is to relate probability to proportion. We can view probability as the proportion of times that this event would occur if the event was repeated many, many times. So let's go back to our sampling frame for an example. If we make many, many random selection of units from a sampling frame, the proportion of times a specific characteristic will appear is the same as the initial probability of obtaining that characteristic. What's important to note here is that proportion and probability don't converge until you repeatedly have random events. Over and over and over again, we randomly sample. So let me give an illustration of this using R. If you want to follow along, I'm going to use the script entitled Sampling Probability. The first thing I'm going to do in this script is load the student roster from Somewhere College. Recall that that student roster has, as one of its variables, the class of each student. So let's take a look at that. So here we see the classes of the various students, along with the probability, or rather proportion, of each class. Now, what I'm working on explaining to you today is that proportion also equals the probability of randomly selecting a member from that class. And with many, many selections, the probability and proportion can be shown to be equal. Now, mathematically, what we mean by many, many is an infinite number of selections, and I just don't have time to do that. But we can get pretty close with taking lots of selections. So let me show you how that's done. First of all, the next thing that I do here is I show you the actual proportions for each group. We can see in the main that they're approximately equal. But now, drilling down a little bit further with our actual proportion statistics, we see that we have 25% proportion of 0.25 in the freshman class, about 6% sophomore, about 4% junior, and about 25% senior. Now let's take a random sample of 50 students. Here's a bar plot showing what proportion we got of each class when we took a random sample of 50 students. A random sample of 50 students includes 50 random events. And so here we are seeing the outcomes of our 50 random events. I could not predict that there would be fewer freshmen in my sample than any other class. This is a random event we're talking about, and in the short term, there's no way to predict what will happen. If I were to take another random sample and do it again, in fact, let's go ahead and do that. You see, we have a different outcome. In fact, just the opposite happened. Instead of fewer freshmen, I have more freshmen than any other class and substantially fewer seniors. So both of these were random samples of 50 students, and they both resulted in different outcomes. When we have random events, we cannot predict a particular outcome. And every time I take a random sample of 50, my bar plot's going to look a little bit different for each sample. If I get the statistics for this, you see that they're very different from what I had in my population at Somewhere College. In that population, every class had approximately, with a little bit of variation, approximately 25% in each class. Here what we're seeing is that we have 34% in our sample is freshmen. Why? Just because of chance. If I had looked at the statistics for my first sample, we would have had fewer freshmen. Now let's do this again. Let's take samples of size 50 again, but this time I'm going to take 1,000 samples, each of size 50. Remember, every different sample is going to be different than the others, and it's going to be something that we cannot predict what will happen, what happens by chance. So let me take 50 samples, let me take samples of size 50, but I'm going to do that 1,000 times. And when I do that, and now plot what happened overall, look what I get. How about that? I ended up with combining 50 samples, or 1,000 samples of size 50. 1,000 samples of size 50, not an infinite number. 1,000 of them. Each sample is size 50, and when I combined, what happened? In the long run, that is, over all 1,000 samples, I ended up with a distribution that looked very similar to my original distribution. In fact, if I get the statistics from it, about 25% freshmen, 25% sophomores, about 24% juniors, and about 26% seniors. If I compare that to what I got originally, it's very, very close. Not exactly the same. In order to have it exactly the same, I would have had to take in an infinite number of samples. But it's very, very close after just taking 1,000 samples, each of size 50. So what's the take-home message here? The take-home message is that the probability of a specific outcome of a random event is the proportion of times the outcome would occur if the event was repeated many, many times. You cannot predict what is going to happen for a single sample, but you can predict what will happen if you keep repeatedly sampling over and over and over again many times, and that prediction should be based upon your original population proportion. That tells us that samples eventually will reach the population if we keep sampling repeatedly.